In this problem, we're asked to find the exponential Fourier series for the waveform shown below. We look at that function, see it has a value of 2 between 0 and 1, a value of 0 between 1 and 2, a value of minus 1 between 2 and 3, a value of 0 between 3 and 4, and then the waveform repeats. So one thing that we note on our diagram is the period for our function t0 is 4. So omega naught, 2 pi over t naught, 2 pi over 4, which is pi over 2 radians per second. Now, to calculate the exponential Fourier series, we're going to determine C0, which is 1 over t0, integral from 0 to t0, v of t dt. And then C sub n, which is 1 over t0, integral from 0 to t0, v of t, e to the minus j, n omega naught t dt. So there are our tasks. Now, first, let's look at calculating our average value. So we have 1 over t0. Now, if we look at our function, we can see from 0 to 1 it has a value of 2. So now we have the integral from 0 to 1 of 2 dt. And it has a value of minus 1 from 2 to 3. So we have the integral from 2 to 3 of minus 1 dt. So we have 1/4 times 2 plus a minus 1. So that tells us that C0 is 1/4. Now we can do the same for Cn. We have 1/4 times the integral from 0 to 1, 2 e to the minus j n pi over 2t dt. Now remember, omega naught is pi over 2. And then we have the integral from 2 to 3 of minus 1 e to the minus j n pi over 2t dt. So here's where we're integrating. So if we rearrange this, we have 1/2 integral from 0 to 1 e to the minus j n pi over 2 dt. And here we're going to have minus 1/4 times the integral from 2 to 3 e to the minus j n pi over 2t dt. So integrating, we have 1/2, we have 1 over minus j n pi over 2. We have e to the minus j n pi over 2t, evaluate from 0 to 1. And then we have minus 1/4 times 1 over minus j n pi over 2. And now we have e to the minus j n pi over 2t, evaluated from 2 to 3. So again, we're just working through the mathematics now. So C sub n, then we have 1 over minus j n pi, e to the minus j n pi over 2 minus 1, minus 1 over minus j 2 n pi, e to the minus j 3 n pi over 2 minus e to the minus j n pi. And still just rearranging, 1 over j n pi times 1 minus e to the minus j n pi over 2 plus 1 over j2 n pi e to the minus j3 n pi over 2 minus e to the minus j n pi. Now there's our expression for C sub n. Let's go in and actually calculate some of the C's. So for instance, let's calculate C1. Okay, so for n equal 1, we have 1 over j pi, 1 minus e to the minus j pi over 2, plus 1 over j 2 pi, e to the minus j 3 pi over 2, minus e to the minus j pi. Now, we need to do some evaluation. Let's look at the term, for instance, e to the minus j pi over 2. Using Euler's identity, we can write this as cosine minus pi over 2 plus j sine minus pi over 2. And if you remember, that's 0. This is minus 1, so this becomes minus j. E to the minus j 3 pi over 2 cosine minus 3 pi over 2 plus j sine minus 3 pi over 2. Again, this term's going to be 0, and this is going to turn out to be j. And then let's look at the e to the minus j pi. Okay, that's cosine of minus pi plus j sine of minus pi. And that's 0. So this turns out to be minus 1. Remember, cosine of minus pi is going to be minus 1. So C1, then 1 over j pi times 1 plus j plus 1 over j 2 pi times 1 plus j. So we have 1 plus j times 1 over j pi plus 1 over j 2 pi. And this evaluates to 0.6752 at an angle of minus 45. Now, we know that c of minus 1 is just the conjugate of c1, so it's 0.6752 at an angle of plus 45. Now, let's calculate c2. We'll have 1 over j 2 pi times 1 minus e to the minus j pi plus 1 over j 4 pi times e to the minus j 3 pi minus e to the minus j 2 pi. So we have an e to the minus j pi, and we've already evaluated it to be minus 1. Now let's look at e to the minus j 2 pi, which is the cosine of minus 2 pi plus j sine minus 2 pi. Now we know that's 0. So this turns out to be 1, and e to the minus j 3 pi is cosine minus 3 pi plus j sine minus 3 pi. This is 0. So we're left with minus 1. So C2, 1 over j 2 pi, 1 minus a minus 1, plus 1 over j 4 pi, times a minus 1, so we have 1 over j pi minus 1 over j 2 pi. That's 0.1592 at an angle of minus 90. C of minus 2 we know is a conjugate of C2, so it's 0.1592 at an angle of plus 90. And then let's calculate C3. So C3 is 1 over j 3 pi, 1 minus e to the minus j 3 pi over 2, plus 1 over j 6 pi, e to the minus j 9 pi over 2 minus e to the minus j 3 pi. And we really calculate these the same way that we do the others. This becomes 1 over j 3 pi times 1 minus j plus 1 over j 6 pi times 1 minus j. So C3 becomes 0.2251 at an angle of minus 135. C of minus 3, which is a conjugate of C3, is 0.2251 at an angle of plus 135. Now, we can actually go in and write the Fourier series, the exponential Fourier series. We know that V of t is the sum from n is equal minus infinity to plus infinity, c sub n, e to the j, n omega naught t. So we'll start off, and we'll have our c of minus 3 term, 0.2251, e to the j, 135 degrees, e to the minus j, 3 pi over 2t, plus the c of minus 2 term, 0.1592, e to the j 90, e to the minus j pi t, plus the c of minus 1 term, 0.6752, e to the j 45, e to the minus j pi over 2t, plus the average value of 0.25, plus c of 1, 0.6752, e to the minus j 45, e to the j pi over 2t, plus the c of 2 term, 0.1592, e to the minus j 90, e to the j pi t, and then the c of 3 term, 0.2251, e to the minus j 135, e to the minus j, e to the plus j, 3 pi over 2t, and then we could write more terms. But here, c of minus 3, c of minus 2, c of minus 1, c0, c of 1, c of 2, and c of 3.